5 asking us? There wasn't stuff sitting there, was there, when you came in?
Nope.
Nope. This is a mystery then. There was nothing sitting there, huh?
Nothing.
No, I'll figure that out later. Okay, so with 5, orientations of a figure and its reflection are related. Did somebody answer that one? Is that right? No, I'm in the wrong lesson, my bad. I was gonna say, geez, that was then. Oh, trace the diagram, draw the path of the shot that would get the golf ball A to bounce off sides M and N, and into hole B. So, would I be really bad if I didn't do it, but I would sketch the idea of what you would do? Okay. So it's gonna be a sketch. Okay, so we've got to go A to B. So, and it's got to go off of this wall and that wall. So, I mean, if I was just gonna kind of eyeball it, it might be something like this. Is that okay? Sort of? Okay, so then in order to figure out exactly what angle it needs to leave at, we've got to do 2 things. You know, first of all, if it's going to go this direction, and some of you found out yesterday that this can be done both directions. You can go forward and you can go backward as long as you just follow everything in sequence. But if we aim that direction with the ball, we have to have a target out here somewhere to hit. Imagine that. And so this has got to keep going out and hit that target. But it's going to bounce off the wall. And it's going to come back. So here's what I do. I look at the target, and then I think backwards. What is the last side that gets hit? So it goes from M to N. So then I go and reflect B over N. So if you reflected B, we're going to work in purple. So if you reflected B over N to get B prime, and then go to the wall before that has to get hit, which is M, extend it nice and long, and then reflect B, up over that. So this point up here ends up being the target that you aim at. So you take a straight edge and you draw that line, and then from this point here, you take a straight edge and connect it towards B, and you draw that line, and then from here you just draw right over to B. And you will find that these 2 angles will be the same, and these 2 angles will measure the same when you do that. There. Possibly. Is that okay for this one? This is 5. Okay. Do you want to see how to do it backwards real fast?
Yeah.
Okay. Reflect A over M. Extend N up, reflect it over, and then aim from B to that reflection. Draw the line, and then you look at the reflection of A up here, and you draw the line towards it, and then back. You can go forwards or backwards, it doesn't matter. I mean, you were doing it the opposite direction of what I showed yesterday, but it works. You just have to go in order, either forwards or backwards. Okay, so for 6, so we got to trace the figure, and then a billiard ball passes travels along the path, mark the angles that are equal in measure. Oh, so it goes from P to Q to R. And that's like line M or something. Okay, so,
I was really only confused about part B when it said label the angle of incidence and angle of reflection.
okay, so you're supposed to draw this, is that right? And then we're supposed to label the angle of incidence and the angle of reflection. So, is it incidence between that line and the line of reflection? So this is the angle of incidence. And where's the angle of reflection then? Is it this one? Okay, and they're equal to one another, right? So if it was, the ball was going the other direction, then incidence would be the angle that's created as it comes in. Okay. Now where are we going? Was that like 8, 9, and all that kind of stuff?
8 to 11.
Okay, so that's a lot. I'd have to charge admission for all of that. Maybe we gotta set them up and not finish them all out. Let me do this. Let me ask you, how many of you have number 8 as a question? Okay. How about number 9? How about number 10? And how about number 11? Oh, I thought we were doing 11. So it's just 8, 9, 10-ish. So 8, a lot of you, right? Okay. Because I think what we can do is we can help some of you individually. Because I hate to just do it for 1 or 2 people. So let's look at 8. Draw the path of the shot that would get the object ball B to bounce off the wall Y so it goes into the pocket 1 without hitting ball D. So where's pocket number 1? Upper right-hand corner. Where in the world am I going? Okay. It's not real clear, but that's okay. So B has got to go off of Y. Here's B. Got to go off of Y.
But I think you have to hit the
It's got to go into here without hitting that, right?
You have to hit the C ball to be it. Like,
Really?
I think so.
Well, it says draw the path of the shot that would get the object ball B to bounce off the wall so it goes into pocket 1 without hitting D. That, I don't, yeah, so I don't think it says anything about C, other than the fact that C is there.
But don't you have to hit the, like,
That's
one
number
ball
9.
to,
Yeah, number 9 talks about C. So for number 8, you've got to get it down here to number 1. And you're not going to bounce it this direction and over, because D is going to get in the way. So what I think you have to do is you got to take it all the way down to this side, and have it come back to pocket number 1. So if you're going to get B to hit X, and then reflect back to pocket 1,
it has to hit off of Y.
Oh, it does have to hit off of Y.
Yeah.
And X.
Oh. So that if it's gonna hit off of Y, I don't know that you can get to go this direction, can you?
Yeah,
You can?
I didn't.
You did? So you reflected B out here and called it B prime.
Yeah. And then went out the other side.
And then did what?
And then reflected it like
You reflected over this?
Yeah.
So you reflected it over here, and then you could aim like that, and it's just gonna go in?
Yeah.
Does it actually work?
Well, it's not really taking the size of the actual ball. It's just coming like in there. So it's not gonna like
Okay. Do you mind if I get down here a little?
Sure.
You okay?
Yeah.
All right. So let's look at this. Oh, that's hard to see, isn't it?
Yeah, it's hard to see.
It's like impossible to see. And what she did is, she has an angle going like this, aiming, so what you did is reflected B over both of these,
Okay.
and then what you did is you aimed at that, so it goes like this, but then you have it bouncing back. But if you look at the angle of incidence and the angle of reflection, they're not equal. So, if we reflect this over, then we have to look at this as being the target, and then the target would have a line that would be drawn as such. Now, I don't know if you can get the ball to sneak by, but if, for example, this got reflected somewhere out here, then you have to have this type of a line. You would have to have a line that goes across here. Well, that doesn't show up at all. This isn't gonna be great, but then you're gonna have to have a line that shows up across like this. And I think what happens is the line gets really, really close to that ball. Maybe it works. If we call this along here the edge of the pool table, then B prime is probably gonna end up being there. And when I look at that, this is gonna run into the ball, which is right here. So I don't think it can reflect off of Y and go in there, unless it reflects off of more than just Y. Has anybody got it to work? Do you have it to work?
I bounced B off Y and then X and then got it in.
So you used two cushions. You started on Y,
And then I reflected B over Y, and then I reflected B prime over X, and then I connected.
okay, so you reflected this over, and then you had an imaginary line down here that you reflected this out here, so it would have to be a little further away.
Yeah, I used to use
So you took B prime and you reflected it way out here, and then from, or that B double prime, you would draw a line to the pocket number 1, and then it goes in. So you have to do it over 2 cushions. That's number 8, but number 9, they want us to include C somehow. So we want to draw the path of the shot that would get the cue ball C to bounce off of X before hitting B. So this cue here has to come off of X and then hit B. So all we're looking at is something roughly like this, although that's not real good. But that's what we need to do. So in order to just bounce off of one side, we need to have a target out this direction somewhere. So if you take B and reflect it out here, and then aim the cue ball at that, then you can find a point that'll hit the cushion here and go directly back to B. That would be number 9. and then 10. Where a laser beam is reflected off mirrors of the x-axis and the y-axis. So this is on a coordinate plane. The x-axis and the y-axis. The line y equals 10 and the line x equals 10. So did you put this on graph paper? So there's two of you, right, that have this one. So let's do this while we're working. Either Joan or I'll come over and look at it with you since there are just two people that worked with it. Okay? And then we're going to jump ahead into the next lesson, which the big part of this lesson is new nomenclature. Because I don't think you guys have seen anything called composition of functions yet. Or composition of functions. So I think what I'm going to do is I'm going to try to explain to you some of the wording of this, and then we're just going to do one, maybe do a couple of measurements on it and such, and then cut you loose to do some of the work. So we've seen something like this before, like the reflection over line M of maybe a point A could be turned into A prime. We've done some of that type of writing of what we're doing. Now, if you look at this, this is the reflection of M. I'm sorry, the reflection over M of what's in the parentheses. So what we can do is we can kind of look at something more complicated if we remember that this is the reflection over M of what is in the parentheses. So now what I'm going to do is I'm going to say that the reflection of a point A over N is going to go into the parentheses. So now the result of this reflection, which is going to be like some reflected point, is going to get reflected over a different line. And back up. So we're just reflecting over a single line. We're saying that we're going to reflect that point over that line. And it's going to give us a result. Here we're saying that we're going to take the result of this reflection, where it ends up, and then we're going to reflect it over another line. So to picture that, if you had two lines, and you take a point A, and let's see, I better spread my lines out. And the top one's going to be line N, the bottom is M. So if we look to the right of this statement, we work from the right to the left, and we do this first. So if I was to take N and reflect it over here, that would become a point. And then if I took that point and reflected it over M, then this goes out here. So it's a composition of two things happening. It's not just one step, it's two steps. And if you take a look at it, it moves this far, and it moves this far together. So the distance is more than just, again, as far away as it was from the original reflection line, but it's that far away, and then this as well. So it's a big jump. Now, if we did this, if we wrote the reflection over n of the reflection of B over M, then maybe I could do something like that. I could start with B, and we would have to do what's on the right first. So we reflect it over M, so it's going to end up out here. And then you take that result and you reflect it back over N. So now you look here, it's to N, and now it's going to go way up. It's going to end up really far away. So it jumps over one, and then it jumps back over the other. So you can do these in any order. But you have to read the directions of the composition from the right to the left. And we do this in algebra too. We do this with equations as well. And what's nice is we always read it that way. The second thing that's listed is what gets done first. And that's probably the easiest thing to get mixed up on with this, is wanting to reflect over that line first, but we don't. We take the results of this one and reflect it over that. So we got to do this work first. So let's see, I'm just trying to think how, what they have for us to trace is so very small. I really don't want to do it. But, you guys have your rulers? Yeah, the rulers are really handy to make two straight lines with that are parallel on each side. So why don't you draw yourself two parallel lines using your ruler. Yeah, notebook paper?
Can they be like at an angle? Or
Yeah, they could be at an angle. Just make sure you have plenty of room to work with.
like a whole page?
Half of a page for sure.
You have a ruler I can borrow?
Did I give you one yesterday too?
You gave me a protractor. It's alright, I'll figure it out.
You gonna hold your dad, have him bring one from June tomorrow morning.
Oh, I can just use my compass.
There you go. Use straight lines.
Those don't look parallel.
No, they don't look parallel, do they?
Just put the symbol on.
They are parallel now, I know. This is gonna be parallel now, Cole, regardless of what you say.
Okay.
There, now they are parallel. And then what I'm gonna do is I'm gonna go on one side up here. I wanna have a little triangle. And if you wanna look at page 202, you've got a little scalene triangle there. Yeah, as long as it's a unique shape that you're gonna be able to see what happens when it reflects. That's cool. And then we want to label it. If we label it similar to what they have, it'd be counterclockwise. A, B, C. And then we've got the lines that are gonna be called M and N. Now, what they want us to do is they want us to fold our paper and do that, but I don't wanna do that. I think you guys are beyond. I think you can do reflections pretty well. It's only 3 points. So what we wanna do with this is we wanna do a composition of reflections. And I think what we should do is we should go over M and take the result of that and make it go over N. So if I was gonna write that as a reflection, so we wanna go over M first, and then keep going and flip it over N. How would I write that as a composition of reflections? So it's got a reflection over a line, and then it's gonna be a reflection over a different line of the triangle ABC. So which line do I list first if I'm gonna go over M first and then N? Yeah, and then N. So we're gonna do this reflection first. So take ABC reflected over M. And if you need to move your N further away, because we want it to reflect over and then keep going, you can do that. And then reflect it over N.
You have to move N.
Shouldn't have to?
No. Might be more fun.
Well.
They'll get the same result.
They will get the same result, that's true. Yeah, just let it flip. Yeah, I got nothing but time, right? Get done with this section, you guys will be able to get a job at a carnival designing mirrors. Mirrors. You ever go to the carnivals down in the States, they got all kinds of, they have rooms with weird mirrors in them and everything. There's rooms where you can run around and break your nose. One notch up in the corner. Lots of it. I know. You're always planning better than me. Then the first reflection, label that A prime, B prime, C prime.
Where? Oh, yeah, right. Ah. Yeah. Who's that? Yeah, the closer line reality,
Oh, yeah.
a little more fun. But still don't have the same relationship we're looking for. Where's your book? Look ahead and see what's gonna be asked of you next.
What pages?
Oh, that's pretty lame.
24.
Oh, I'm gonna call that better. You done? 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 You done? You done? Cool. You guys don't have a triangle, do you? Triangles are fun. Let's do triangles to do the perpendicular lines, so the parallel lines.
Now? They're done constructing.
Yeah, but all you have to measure.
Do you wanna hike up there 30 times? Just for like 30 minutes, just to drop the transmission.
No, you can't keep these out.
They have like
So many of
one
these.
place.
They're hard to come by right now.
Ruler wouldn't do it, huh?
What's that?
The ruler wouldn't do it?
I don't think it really does it, because it's nice to be able to measure at a 90-degree angle quick and easy.
No,
But they're all lined up,
transmissions almost have to.
so
Yes, it is.
Yeah, I guess they're all lined up. We can find out if they're all lined up. Are they all lined up? Mine aren't lined up.
yeah, they look pretty good
Do
actually.
they really?
Yeah.
I cheated a little. All right, so I gave you a triangle, I guess I didn't need to, but
Break 'em.
you can use them. So if you lay yourself out like this, and you find, there's a point, then you can draw a line between all three of these corresponding points. Just pick one of them, A, B, or C, it doesn't matter. So you're gonna draw a perpendicular line that's gonna go through the pre-image and each of the images. And then, with this composition of reflections, how far did your pre-image move? Measure that. Measure it as accurately as you can. How far your pre-image moved. So I'm looking at how far did I go from A to A double prime. Millimeters,
Yeah.
centimeters to the 10th. I gotta do mine in inches. Well, I guess I could also convert it really fast, right? 32.4.
That one's working. Well, they're all in line.
Okay. See how that distance? Okay. Before we go any further, your pre-image and your final image. What's the relationship of their orientation? They're the same, aren't they? Okay, so if you have like A double prime as a distance, what do you suspect the distance of B double prime is?
The same as
It sure looks like the same, right? Because you're just, and then C double prime. So that means any corresponding point on this original figure in the final image, they probably moved the same distance, right? Okay. So you have your distance written down, like this. The distance between A and A double prime, or whichever two you measure, the distance between. Now find the distance between your two parallel lines. So find out how far are they apart. So what's the relationship between the distance between the lines and how far your image moved?
they have
The distance is half of, or it's,
half of
the distance between the lines is half of the distance that the image has moved. Are you all finding that? And you all had unique triangles and unique line distances. So we tested it, 16, 18 times. Came out the same way. So if you look on the top of page 206, they say two reflection theorem for translations. And they write it differently here. So, they say if two lines are parallel to one another, then they say the translation, and they say reflection over n, and then they have a little circle. That means composed with. The reflection over m. So this right here is exactly the same meaning as what I wrote here. It's just a different way of writing it. So this could be written as the reflection over n composed with the reflection over m. And again, you do the second one first. So here you reflect over m and then over n, just like what we did. So that this reflection, this composition of reflections, has a magnitude. What does magnitude mean?
It's like the angle, but also the direction angle from it.
It could be, like if we're talking about angles, we're talking about the magnitude of the amount. Yeah, so like when the minute hand is going around and it goes 3/4 of the way around, it has a direction, either positive or negative, but it has a magnitude, and that magnitude up here might be an angle. Here, that magnitude is a length. So it's an amount. That's what a magnitude is. So it has a magnitude 2 times the distance between m and n. So that's one of your theorems. It's in the back of your book. And it's in all of those papers that you guys have got. Oh yeah, hey, while I have you all here, the next time that we have a quiz, next time that we have a test, forevermore, if you're going to use your theorems and postulates, you need to have them on paper like this, not in the book anymore, okay? And make, not in the book. Well, these are in the book. That's where they're copied from. But if you're going to be using them on a quiz or a test, you need to use these kinds of paper copies, not your textbook copies. From now on out. Let it go a little bit, but we're almost halfway through the year.
Wait, what are you talking about?
So we So we can use that, or we
So,
can't?
yeah, so whenever we're doing quizzes and tests, you may use this, but I'm not gonna let you pick up your textbook because you forgot this in your car.
Um,
There, is that, we put it in those kinds of words, is that better?
Yeah.
Okay, yeah. Yeah, like a real life situation. Oh, it's at home. Well, that's good. At least you know where it is. All right, another way. Sometimes what they'll do is they'll give one of these reflections or these functions, these things that's happening, they'll give it a capital letter. Like the book uses T and S. So T might be defined as the reflection over line N. It could be defined as all kinds of different things. It could be an algebraic expression even, we'll learn that stuff next year. But if T is some function that you do, and S is another function that we do, we can write it like this, T composed with S. So there's lots of ways that we can write this. But there's one thing that's consistent, is the second function always gets done first in a composition. I think that's enough for you guys to work.